Good morning, everybody. I'm going to have a look at a few formulas, operator precedence, and then what happens in the memory of the PC with the variables. So at this stage, you know already the mathematical operators that we would be using in programming. This is used everywhere on the PC. So if you in Excel wants to multiply two numbers, it would be the asterisk that you're going to use. And if you want to divide two numbers, it would be the forward slash that you're going to use. The first important thing that you need to note is the operator precedence. And I only gave you the most important ones for now. So first of all, in programming in general, and this does sometimes differ between languages, but under normal circumstances, we've got multiplication and division. That would execute right at the start if operators are combined. So if I've got 5 multiplied by 8 plus 2, what's going to happen first? All the multiplications in that formula would first be executed from left to right. Thereafter, we've got addition and subtraction, again from left to right. And as with mathematics, parentheses can change the order. So have a look at the following examples. If, let's say, I've got 5 plus 2 multiplied by 6, and I'm just using numbers now, those numbers can be replaced with variables once we go into programming. What would execute first? The multiplication on this line. So first 2 and 6 would be multiplied, I get 12, and in the next step 5 would be added to 12, the answer would be 17. Okay, it's important that you understand how things would be executed in a formula. If I change the order, if I add parentheses, then 5 would be added to 2 first, I get 7, and in the next step 7 and 6 would be multiplied, and I get 42. Excuse me. If I've got something like this, 5 times 2 times 3, then the 5 and the 2 would be executed first, I get 10, and then the result of that, 10 would be executed, or would be multiplied by 3, and my answer would be 30. If I've got a situation where I've got a bit of a more complex formula, then in this case 5 and 2 would be executed first. Remember, multiplication from left to right. I get 10. Thereafter the 10 and the 3 would be multiplied, I get 30, and now only 44 and 30 would be added together, and I get 74. Let's take a last example. So let's say I've got answer. It's 9 divided by 3 times 2 plus 5. So what will execute first? It's multiplication and division first from left to right. So 9 divided by 9, 9 divided by 3 would be 2. And I've got the multiplied by 2 plus 5. That still needs to happen. I'll show you step by step. So next step would be 3 times 2. I get 6. Add 5 to that. And now the answer would be 11. 6 plus 5 is 11. Let's just go with one more exercise like that. Let's go with 15 divided by 3 plus 2 multiplied by 4 divide by 2. Okay, so what will we do first? Multiplication and division from left to right. So first of all, I've got 15 divided by 3. I get 5, and the rest of the line follows suit. As the next step, I will have the 2 multiplied by 4. So I get 8, and the rest appears as is. Okay, as the last step, or second last step really, 8 divided by 2 would give me 4. And now I've got the answer. 5 plus 4 will give me 9. Okay, so real important that you know what would happen first, next, and next until a formula is completely solved. Okay, I want to have a look at a few more exercises. So, let's say I've got a program that asks the following. Accept the sales price, calculate the discount of 5.5% on the sales price, or let's say of the sales price, and then calculate the final price, display the final price. Okay, so discount, that means I will have the following variables. Sales price, discount percentage, and discount percentage is a fixed value. It's given in the problem statement to me. So it's all uppercase characters, and I assign that already. You have the option of assigning it like this, but then in your formula you'll need to divide by 100. So I like to already include the value as a percentage out of 100, like that. I will need the discount amount, and I can abbreviate, not just an A, but AMT, short for amount, very acceptable. And then the final price. Take note, I went with nice and descriptive variable names. So at this stage, the description, a little bit optional. If I then have a look at test data, and I'm only going to use one set, and right at the start, the very first set, make that extremely easy values, things that you can calculate without really using a calculator. So if my sales price were 100, then the discount amount, remember discount percentage stays as it is always. I don't need to repeat it. Discount amount would be 5.5, and the final price would be 94.50. So for the second set of values, we can go with something a little bit more complex. And now you can take your calculator, and we can work out 254.45 times 0.055 gives me 13.99. Computers will not round the value for us. This will just, so computers won't round the value for us. I'm just for now going to write it. Apologies. 13.99.4. Just like that for now. So that means if I go and subtract 254.45 minus 13.994, I've got 240.456, like that. And we can go and work out a last set of values. For simplicity, I'm just going to use something like that. So this gives me 55 Rand, and that would give me 9.45 on the dot. Okay, I've got my 3 sets of test data. The test data is important because this is what I'm going to use to test my program, to make sure that my program works. Okay, so let's go have a look then at the steps for the button event procedure. First step would be declare the variables. Then I need to get the sales price from the user. Calculate the discount, and I'm just moving that so that we can see everything. Step 3, calculate the discount amount. Step 4, calculate the final sales price. Step 5, display the final sales price. Some of you asked, where do you get the formulas? Well, the formulas you need to develop on your own. The formulas would be in the set of common things that every human should know. So you should know how to calculate a discount. With a little bit of experience, you're going to get better at it. Okay, so these are the steps. And now the crucial important thing. I want to go show you how this would be executed in the memory of the PC. Okay, so over there at the top we've got the problem description. Accept the sales price, calculate the discount of 5.5% on the sales price, calculate and display the final sales price. I've got my input, other and output variables, and I've got the steps, and this time around I've numbered the steps so that I can easily refer to them while we are doing our presentation. So let's say step 1 is executing. Declare the variables. What happens in the PC's memory? Sales price, discount percentage, discount amount, and final price would be declared. That means a little block would be opened for them to store their data. Everything that's just declared will get a 0 value by default. This differs a little bit between languages. In Java, for example, there would be no default value, whereas in VB, the language that you guys would most probably use, and quite a few of the other languages, a default value, so 0, would be assigned. Discount percentage gets the value that's assigned in the declaration. So 0.055. So step 1 is executed. Declare the variables. Step 2, we're going to ask the user for the sales price and get that. I'm just going to quickly move something to our screen. So let's say this would be my test data. And let's go with the first set of test data. So the moment that the user gives me the value, it would be stored in the variable. So, apologies. Step number 2, the user gives me the sales price. The sales price is saved in the variable sales price in memory. So the drawer is opened, 100 is placed inside that drawer called sales price. The drawer is closed. Step number 3, calculate the discount amount. So what happens now? In the computer's memory, the value inside the drawer called sales price would be retrieved. So have a look over here. I've got 100, and then the value inside discount percentage would be retrieved. which would be 0.055. And now we can do the calculation. 100 times 0.55, and the result will be 550. Now the moment that this formula is finished calculating the value, the result, computer is going to take that and save it in the place where we specified. So we specified that the result must be saved in discount amount, and that is what would happen. So step 3 would be finished, and discount amount stores now the result of the calculation. Step number 4 says calculate the final price. So in this case, again, all the variables, their values would be retrieved. I'm going to write that right at the bottom. So sales price, I've got 100. Discount amount, that drawer called discount amount is opened, and the PC takes whatever is specified over there, and I've got that. So 100 minus 5.5, and the result will be 94.50. And that result then we said must be saved in final price, and that is exactly what the computer will do. It saves it in final price. So every variable listed in my formula, that value stored in the variable would be used whenever the computer sees the name of the variable. So if it sees discount amount, it retrieves the discount amount saved in the variable. And then wherever we specify the result must be saved, that result of my formula is saved in the variable over there. And immediately you can now see, as I said before, this sign over there, it's not an equal to. In mathematics, equal to means value is the same on either side. Okay? In programming, this is the assignment statement. We might say equal to because we're used to the mathematical concept. But this really means take whatever you've got. Let me do it like this. Take whatever you've got to the right. After you've done the formula, save it in the variable listed to the left of the assignment statement. Real important. Step number 5 will display the final price. It will retrieve the value saved in the variable, and we're going to display to the user however it is needed, in exactly the manner it's needed. Okay, real important that you apologies, that you understand how the memory of the PC and the variables works. Let's have a look at a final few examples. So program B might say get the product price, calculate an increase of 6.5% on the product price, display the increased price. So my variables might be input for product price, other increased percentage and increased amount, output the increased price. And I've only got one set of test data here. We will in normal circumstances add 2 more, but 1 is good enough. So if the product price was 100, the increased amount would be 650, and the increased price 106.50. Remember, we don't use signs. No dollar, no rand, no any sign like that in programming. So my steps for my button calculate event procedure would be declare the variables, get the product price, calculate the increased amount. So again, I'm just going to move that to a new line. Calculate the increased price and then display the increased price. Okay? And again, I want you to now go through these steps, write down on paper what would happen in the memory of the PC. See if you can follow that. See if you understand what it can do. Let's say you're asked to add 100 Rand to the total price. How would the formula look? I will take my initial or current price, add 100 to it, and save the answer in the same variable. Okay? So add 100 to total price, my formula would look like that. I take total price, I add 100, and I save it again in the same variable. Let's say you're asked to assign 50 to the price, and have a look, the wording is now real important. So assign means save. That means I'm literally asked to put 50 in that memory block in the variable. And the way to do that would be to say price is equal to 50. That means take 50 and put it in price. And again, no signs. Do remember, no signs. Next, I want to have a look at the difference between formulas in mathematics and formulas in programming. So for now, I've got 3 different formulas, and we're going to have a look at how that would be represented, obviously on a flat line in a computer program. So I'm going to use the exact names as it appears in the mathematical formulas. Remember, we will very often have variables. So the first one will be represented like this. With the parentheses, I'm going to explain that A and B must be added first, and then the result divided by 2. Second example, x is equal to 1 plus r divided by 100. Over here, parentheses would be optional. I can add these, but I can also leave it out, depending on the programming language that would be used in the end. Division will appear before addition. So that means if I leave out the parentheses, my program, while the program is executing, will automatically divide r by 100 first and then add 1. So over here, it's optional to add the parentheses. So it means either this or that. Let me just fix that. Is acceptable. If we have a look at the third example, x is equal to b multiplied. Now I need the parentheses first. 1 plus, I copied the wrong thing. And again, it's optional to add the parentheses, but maybe it's good for a better explanation of the result. Let's say I've got slightly different last example. Let's just go for, and I'm just adding something here, 2 times, let's go for C. Remember, in mathematics, the multiplication sign very often represented as an X. So let's say I've got something like 2, let's just rewrite that, it's a much better. A plus B times 2C. Because that would actually be how it is represented in mathematics. 2 times C, 2C. Put that nice and simple there. My formula will thus look as follows. X is equal to, take A and add B, and then divide the result by 2 multiplied by C. Okay, I need to now, in programming, state the multiplication explicitly. So I need to state that there's going to be multiplication. And both the A plus B and the 2 multiplied by C will appear in parentheses. This will first be executed, that next, and then the 2 results will be divided upon one another. Okay, now we get to a few more difficult exercises. The first one, x is equal to a to the power of 2, can easily be represented like this. A to the power of 2 is the same as a multiplied by itself. But if we now get to a situation where a is a to the power of 5, then the formula gets a little bit lumpy when we need to multiply a times a times a times a like that. So in programming, very often mathematical functions are provided to us, and over here I've got the mathematical functions for Visual Basic. I'll show you how to look that up. And there's quite a few, shall I say, common mathematical functions provided to us. There's a list of all of the things, but I'm going to only concentrate on 1 or 2 important things. Absolute gives me the positive of a value always. I'm going to jump right down to power. So this would now be a to the power of 5 or something like this. That would help us. And square root. So I'm only going to look at power and square root in the exercise today. So over here they tell us the power function will give me a number raised to a specific power. If I go click on it, it shows me how to call it. So this is now, let's increase the size over here a little bit. The function is called power, P-O-W. Something new that you need to learn and get used to. I'm going to send 2 things to it. These 2 things are called 2 parameters. So I'm going to give it 2 numbers. The first number would be the number that I want to raise to a power. The second number specifies the power. Okay, so I'm going to give it two numbers. The first number it says over here is the number sorry, I want to raise to a power. The second number I need to give it is the power. Okay. Now this function is something that another person already coded for me, and I can simply use it to get a result. So it's like a little section of a program. Okay. It's called a method. For now, you can ignore the stuff that comes before power. We need to pay attention to the name and then the what it wants. And this data is actually given to me in C#, I see. I'll quickly going to have a look for the VB data. If I scroll up a little bit, it's easy for me to choose the different languages. For Microsoft, C#, VB, F# and C++ would be available. So if I say I would rather like to see how the function looks from a VB language perspective, then it's exactly the same. I need power and I need two parameters, the number and then the power. And over here I can see it gives me back a number. So in programming, I'm going to do the following. I can specify from the mathematics class. Let me go back a moment. The class is called math, and here at the top it shows me math.power would be the name. The class name is like a surname. So this is to say your surname and what would be the name of the method. Math.power and I need to give it two numbers, a to the power of 2. So any one of those would be fine. If I move everything down over here a little bit and I add a second formula, let's say x is equal to a to the power of b. Let me just change that so that the power of is indicated nicely. That's why I'm using Paint. It's an easy way for me to play around with the data. So that means in programming I can write this not really as a times a, because I don't know how many times a must be multiplied by itself, but I can very easily specify, call the power 2 method, situate it in the math class, give me the result of a to the power of b. Like that. So, whenever I use a mathematical function, I need to know what data to give to it, and the sequence of the data is important, and I'm going to store the result. If I look at the third example over here, x is equal to the square root of a. If I go back to the list of methods, and VB is still selected, then I've got lots and lots of Methods, let me just quickly find what I am looking for. In this list, scroll down until I get to square root. So, over here I can see what is the name of the method, math.squareroot, and I can see it takes one number. Double means it takes one number. And here it tells me what does it take as a parameter, what must be sent to the square root function. The number whose square root is to be found. So that means if I go back, my formula in mathematics will be math.squareroot. I need to have that name exactly right. And when I write the programming code, Visual Basic will help me. Get the square root of A. If I get to a little bit more complicated formula, I've got B multiplied by, and let's just do the part in brackets first, 1 plus R divided by 100. But I need the square root of that. No, not the square root, the power, sorry. Math dot power of, first do that, then give me the power to the value of n. So n is the second thing. This all is the first value included in the parentheses, and power of next value. So for the last example, I need the square root of. Let's go and first work. What is math to the power of A 2 plus, I need to call math power B 2, and then I need to add those two together. So those brackets, and now I need math dot square root, and there my line breaks up. So let's just increase that slightly, and I can just move my formula up a little bit. Might be a little bit easier for you to see. In programming, I can easily continue on the next line when needed. Let's just move this up a little bit. Make sure everybody can see the last exercise. Okay, I just minimized everything a little bit so that we can see the different formulas quite easily. So if I need to get the square root of quite a value, math.squareroot, and I've got, let's use a different color, this big bracket in the outside to specify it's the square root of this whole formula. Whenever I call a function like this, a function call executes before any of the operators. So that means math.power A to the power of 2, and b to the power of 2 will first be calculated before those two results are added together. That result will then be sent to the square root function, and it's going to give us the square root result, which is saved in x. Over here, the second example, what would execute first? Well, right at the start it would be r divided by 100, then 1 is added, then that result to the power of n is calculated, and lastly we're going to multiply that with b. So here it's only the square root of a that would be calculated, the power of a to the power of b, a to the power of b, and this first example, either a times a, but a little bit better, programming wise, would be to use the math function and tell it give me a to the power of b. So now you learned about two functions that we can use in programming: power and square root. You also see how more complex formulas can be written in programming. Thank you.